Okay, so today we are going to talk about complex numbers and adding, subtracting, and solving complex numbers. So one thing we always want to remember is that the square root of -1 is I. So one thing we always want to keep in mind for this video here is that the square root of -1 is I. So if we look at these first three examples, we have negative signs under a square root sign. Negative signs under a square root sign are not allowed. We do not want negative signs under a square root sign. So to get rid of them, the first thing we need to do is break up -72 into the square root of -1 times the square root of 72. Now we just went over that the square root of -1 is I. So now we have I root 72. Now we just need to break down 72 like we normally would. Well, that breaks down into the square root of 36 times the square root of 2. And make sure you bring your I with you. Square root of 36 is 6, so we have 6I root 2. So all we are doing is breaking down the square root of 72, but since we have this negative in here, we have to add an I in our answer. So really that's all we are doing. So here we have the square root of -16. So we have the square root of -1 times the square root of 16. Well, the square root of -1 is I, so now we have I root 16. Well, the square root of 16 is 4, so our answer is going to be 4I. So once again, taking the square root of 16, which is 4, and then just adding an I on it because we have a negative inside the square root. So square root of -48, we have the square root of -1 times the square root of 48. Square root of -1 is I. Now we have square root of I root 48. Now let's break down 48. Breaks down into square root of 16 times square root of 3. So our final answer is going to be 4I root 3. And that's all we have to do. Now, for solving, keep in mind we're solving quadratics, so we have to have two answers. So we always have to have two answers when we are solving quadratics. So for our first example, we have to isolate x squared. Well, that's done for us, so now all we have to do is take the square root of each side. When we do that, we're left with x equals plus or minus the square root of -28. So break down the square root of -28. Well, we have to break that down to the square root of -1 times the square root of 28. Square root of -1 is I. 28 breaks down the square root of 4 times the square root of 7. So our final answer is going to be x equals plus or minus 2I root 7. So for these here, we are just solving like we normally would, except now we have to add an I in our answer since we have a negative under the square root. So without even looking at this next example, we can probably determine what our answer is going to be right away, because 64 is a perfect square. So we know our answer is going to be plus or minus 8I. So we know the square root of 64 is 8. And we just have to add an I with it. So x equals plus or minus 8I. And we have our two answers because we have a plus sign and a minus sign. Now for these here, we have to get x squared all by itself. So in our first example, we have to divide by 2 first. When we do that, we have x squared equals -24. Now x squared is all by itself, so now we can take the square root. So we are left with x equals plus or minus square root of -24. Now we need to break down -24. Well, that breaks down into the square root of -1 times the square root of 24. So we have I. 24 breaks down into the square root of 4 times the square root of 6. So our final answer is going to be x equals plus or minus 2I root 6. For our next one, we have to divide each side by 4. So when we do that, we're left with x squared equals negative 25 over 4. So we've isolated x squared, so now we take the square root of each side. So we have x equals plus or minus the square root of negative 25 all over the square root of 4. Well, we see that these are both perfect squares, and the square root of negative 25 is 5i, and the square root of 4 is just 2, so we have 5i over 2, not 4. Now for these here, we have to get x squared by itself. So for our first one, we have to add 22 to each side. So when we add 22 to each side, we get x squared equals negative 90. So x squared's all by itself, so now we can take the square root of it. So x equals plus or minus the square root of negative 90. Now we need to break down negative 90. It breaks down into square root of negative 1, square root of 90. 90 breaks down to square root of 9 times square root of 10. So our final answer will be x equals plus or minus 3i root 10. And for our next one, we have to subtract 9 from each side. So we get negative 4x squared equals 48, and divide by negative 4. So x squared equals negative 24. Sorry, not 24. 12. And now we can take the square root of each side. X equals plus or minus square root of negative 12, which breaks down into square root of negative 1 times square root of 12, which breaks down into square root of 4 times square root of 3. So x equals 2i root 3. For these two here, you're going to take the same exact steps as you did in the last two. For the sake of time, I'm not going to go through these, but if you want to know what they look like, they are on the notes filled out on my website, so you can go there and look at those. So now on to what complex numbers look like. Complex numbers have a real number in them and an imaginary number. This is standard form for complex numbers. So when we are writing our complex numbers, this is what we want them to look like. So we have 4 plus 3i. A lot of times you will see it as a plus bi, which is just the general form. So if you see that, this is what the standard form of complex numbers looks like. So when we're adding complex numbers, all we have to do is collect like terms. So we see we have a 6 and a 5. We have 6 plus 5, which equals 11. And then we have a negative 3i and a positive 4i. And that becomes just I. And we put those two together to get 11 plus I. And you see that it is in standard form when I write it, my final answer. So over here we have 9 plus 8, which is 17. And then we have an 8 minus 9, which is just negative 1 or just negative I. So all we're doing here is collecting like terms. For this one here, once again, we are collecting like terms. So we have a 10 minus 11, which is negative 1, and a negative 2 minus 7, negative 9. Next one, we have 7 plus 14, which is 21. 3i minus 6i is negative 3i. So these here shouldn't be too tough. All we have to do is collect like terms. Now, so when we are subtracting complex numbers, we have to take this subtraction sign between the two parentheses and make it a plus, and then change all of our signs in the second parenthesis. So now we have a negative 2 minus a 4. So negative 2 and negative 4 gets us negative 6. Then we have a positive 6i and a negative 6i. Negative 6i, positive 6i, that gets us 0i, so we don't have to write it. So our final answer is just negative 6. Once again, over here, change this minus to a plus and change all of our signs in our second parenthesis. So now we have a negative 1 plus 7, which is 6, and an I plus 5i, which is 6i. And last two examples here. We have an 8. Well, first off, we have to change our signs. So now we have an 8 plus 11, which is 19, and a negative 5 minus a 4, which is negative 9. And last one, change our signs. So we have 8 plus 8, which is 16, and a 20 minus 12, which is 8. So it's 16 plus 8i. So when we're adding and subtracting, just remember to put these into standard form, which looks like this with the imaginary number at the very end. And when we are solving, make sure we add the plus or minus sign in, because we always have to have two answers when we are solving. So if you want to see the examples that I did not get through in this video, just go ahead and go onto my website and look at those on the notes filled out section, and everything will be right there for you.